So, room is packed. Thank you for coming. This session will be like a small voyage in the history, and we will see what happened to the HTTP protocol over this last 20 years. We will see how the technology evolved. We will see how things that are now called best practices are in fact hacks. And we will also see like a small demo at the end to show you how much better HTTP 2 is with respect to HTTP 1. So this is me. I work for an American company called WebTide. We provide services for the Jetty server container. And so if you need anything related to Jetty and stuff, we are there. We also do JVM tuning. So tomorrow I will have a session about the G1 garbage collector as well, based on the experience that we made helping our clients to tune the garbage collector. So let's go to HTTP 2. Why there was a need to go to HTTP 2? Well, this is where our journey in the past shows. This is the w2c.org page in 1996. As you can see, it's a very simple page. It was one HTML file for 600 bytes. 96 was also the year where the HTTP 1.1 specification was actually made the standard. Okay, so HTTP 1.1 was made for these pages. So we run fast forward to 2015, and this is the same page for the w3c.org, but now this page is 41 resources, 366 kilobytes, 1 HTML, 4 CSS, 2 JavaScript, 34 images. So what happened? That I have a 40-time increase in number of resources that I have to go and fetch from the server. There is a 60-time increase in the number of bytes that I have to download from the server. And still, this page is not even close to the average web page that we have in today's web. This is, for example, the CNN.com page. 95 resources, 6.7 megabyte for 3 HTML, 4 CSS, 30 JavaScript files, and 58 images. Okay? So it's a big, big page. And this is how's the web today. If you're going to put a website online, you have to deal with these with this kind of images and reference and richness of the websites. You cannot just show a page like if it is 96. Okay. So the web basically exploded. And during those past 20 years, HTTP 1.1 has become an old protocol. It's extremely inefficient for today's web. There is no multiplexing. There is no resource correlation. And we'll see in a second what these two terms mean. Web developers are actually now using what they are called the best practices for making the pages faster. Who here is using domain sharding or know what it is? Like few? Or who is using image spriting? A few, okay. So these tricks, domain sharding and image spriting, are actually considered best practices, but in fact, they're just techniques to work around HTTP 1.1 limitations. Okay, so for example, take image spriting. Image spriting is a technique where you have several small images, and you just concatenate all the images together into one big image. Then, using CSS, you crop the image at the right position, and you just show the image that you just cropped. Why you want to do this? Because instead of downloading or requesting to the server 10 images, okay, so for example, you request the image where you're not hovering over a button, the images where you are hovering over a button, the images where the button is disabled, and so forth, okay? You just request one image that contains the three together, and then you just crop them with the CSS. It's a huge complication for developers, and it's just a workaround because HTTP is not an efficient protocol. The browsers also want to make the browser really fast because you choose your browser depending on how fast it is. And so what they're doing, HTTP 1.1 recommended do not open more than 2 connections to a domain. And what browsers do? They open 6 or 8, all right? So that's not good. And why they do this? Because they want more connections for the capability to be able to download in parallel more resources. Imagine if you have the CNN.com website, you have to download 95 resources. You open 6 connections, you make 6 requests, you wait for them to come back, another 6, come back, another 6, come back. By the time you are at 95, a lot of time has passed, okay? But it's not only clients that are really worried about the state of the HTTP, or also servers. Like here, I present you 5 studies that have been made by big companies. So let's take Shopzilla, for example. They modified the landing page from 6 seconds to 1.2 seconds. What happened? They got 12% more revenue and 25% more page views. So because the landing page was faster, they get more money, right? A lot more money. Amazon.com, for every 100 milliseconds the pages are rendering faster, they make 1% more revenue. Amazon.com makes $1 million. 1% of $1 million is $1 million. So it's really, really important. And just to give you a sense of how fast is 100 milliseconds, when we close our eyelids, that's 300, 400 milliseconds. So 100 milliseconds is barely at the limit of the human eye to be able to recognize things. Still, we have this perception that the website is faster and we spend more money on it. Okay? So it's not only a technical issue, it's a business issue. So that's the summary. Better HTTP, more money for your business. That's why everybody wants to go to a better HTTP protocol. So let's see how does it work. So who wants to stay on HTTP 1.1 now? Okay, cool. No one. So let's see for a second how does it work, okay, in a more technical detail. HTTP 2.2 is not anymore a textual protocol like HTTP 1.1 is. It's been converted to be a binary protocol. This is because binary protocols and the way that HTTP 2 has been designed is to improve efficiency for both clients and server to generate and parse the protocol itself. Again, small example here. When you have to parse an HTTP header, not many of you do, but I do because I work on Jetty. So it's always like, it goes like this. Take the first character. Is this a carriage return? No. Take the second character. Is this a carriage return? No. And so forth until you find maybe a semicolon. So the semicolon separates the name of the header from the value of the header, right? And then you have to go character by character until you actually find a carriage return, okay? In HTTP 2, it doesn't work at all in this way. The protocol has been made so much more efficient that we don't need to do this character by character parsing. So much more efficient. It's based on packet of bytes called frames. For example, this one is a headers frame. It contains the request headers that go from the client to the server. Pretty much like a normal HTTP request, of course, because the semantic is retained. It contains the headers. Then, for example, if it's a post request, it may also contain a data frame containing the body of the request. And similarly, the server replies to the client with a headers frame, which this time contains the response headers, okay? And of course, it can be followed by a multiple data frame that contains the actual bytes that you want to download to the client. So for example, the image bytes in multiple chunks. Very simple. HTTP 2 requires TLS if you want to use it with browsers. There has been a movement to move to TLS everywhere, and this is because of the NSA scandal that has been around last year and so forth. But basically, all the bodies, the committee bodies that are defining the new protocols for the internet, they kind of say, we really want TLS to be everywhere. And HTTP 2 makes no difference. So if you want to use, if you want to put up a website and you actually want to use HTTP 2, you have to put it out using TLS. You have to buy the certificates, you have to set up all your infrastructure to support that. Not only TLS, but it also requires a very strict subset of very strong ciphers. So it is heavy encryption that HTTP2 requires. And this is again for the same reason that I said before. Now, this has been done also for another reason, because if you think about port 80, okay, when you go from a client to a server, there are a lot of intermediaries in between your client and your server when you go over the internet. So if it's on port 80, you were in the past sending a textual protocol, but now suddenly you're sending a binary protocol. It could be the sum of the intermediaries in between. They're not being updated to understand HTTP2, and therefore they just say, oh, I see binary bytes here. I don't understand what they are because it's not HTTP, so I just close the connection. So TLS, on the other way, what does it make? It makes a tunnel from the client directly to the server so that the intermediaries just see encrypted bytes. And they just say, oh, I got encrypted bytes this way. Let me just pass them over because I have no way to decrypt them, right? So it doesn't really matter what's inside the encrypted bytes because the intermediaries will just take the bytes and pass them over. This makes a very high it makes very likely for the HTTP2 protocol to actually work out of the box. How many of you have a Gmail account here? Like almost all of you, right? So did you know that you're not using the HTTP protocol in the past 5 years? When you connect to the Google servers in the past 5 years, you were not using HTTP protocol anymore. You were using Speedy before, and now you're using HTTP2. But you didn't notice any difference because of TLS. Because with TLS, it just works. However, this doesn't mean that it's for using HTTP2, you have to use TLS. For example, if you have server-to-server communication, you can actually use clear text HTTP2, okay? This is because you're not using a browser as a client, because browser only do TLS HTTP2. But if you're using a Java client, for example, that speaks HTTP2, then you can just use clear text. So the protocol itself works in both cases. Let's see one of the biggest features of HTTP2. It's called multiplexing. So let's see, how does it work? So the blue pipe is a TCP connection. And when you send a request from the client to the server, you send a headers frame and a data frame. And you open a smaller pipe called stream. This is how typically HTTP 1.1 works. You can only open one stream for each TCP connection. However, in HTTP 2, you can actually open multiple streams in the same TCP connection, okay? And note that these streams have been opened at different times, okay? But the responses may come back to the client out of order, okay? So each stream is treated independently. If this is a fast request to be served, doesn't matter if it's being requested as last, it will come back very quickly as the first response, okay? So they are independent. The fact that I can multiplex multiple streams on a single TCP connection gives a lot of benefits. We will see them in the demo. Another thing that HTTP2 protocol does is headers compression. So if you know a little bit about HTTP, there is many things that are constant in a request. For example, the user agent string. It's a very long string, typically 100 bytes or something, that specifies what browser is it, what resolution of screen, operative system, a lot of information. So this string is a constant, and it gets sent over the network for every single request that you're making. Every single request contains that constant. So how does HTTP2 optimizes this? Well, it uses a technique that works in this way. You send the string first, and then in the second request, you just say, well, you know the string that I sent you before? Here's a back reference to that particular header. So in the next request, you don't need to send 100 bytes anymore. You just need a back reference to those 100 bytes. And that makes HTTP2 very efficient. In particular, we go from 600 bytes of a normal HTTP 1.1 request to about 90 bytes. So you save 85%. Again, imagine if you pay for the bandwidth that you're actually using. Okay? This is a huge saving as well. It's only on the headers, of course, not on the content, but still, it saves you some money. There's another feature called request prioritization, which is a kind of an experimental feature. Not many servers implement it, but the browsers do. It's basically a feature for the clients that they can say, for example, oh, I need this JavaScript. They receive part of the JavaScript, but then maybe the JavaScript blocks for some reason. So they can say, oh, well, you know, the JavaScript haven't received it all, so let me suspend that for a second, and I want to change the priority of that request because now I need this request first. Okay? So the browser can actually tell the server what resource is more important for them and what the server should prioritize in downloading them to you. The other killer feature of HTTP2 is called HTTP2 push. Let me go to the drawing. So what happens when you download the web page? Okay, you request index.html, so it goes to the server, come back the HTML, and then what happens? That the browser starts parsing the HTML, yes? So, and what it finds, oh, look, at the header, I need a JavaScript file now. So let me request a file. Oh, but also I need a CSS file. So let me request a file. And then continue on parsing the HTML, right? So it gets back the CSS, it gets back the JavaScript, and then while it's parsing the CSS, it finds that there is a reference, a URL reference to an image. So it makes another request for a background image that is specified in the CSS. So for this simple page, you need 3 round trips to go to the server and to download those resources. Now, it is evident that these 3 resources are correlated, okay? So the HTML references those 2. So those 2 are basically secondary resource of this primary resource, which is the HTML file, right? So there is a correlation between how we build the web pages today. This correlation was not present at all in HTTP 1.1. However, we have realized that this is important in today's web. And we have built the HTTP2 protocol in a way that supports this kind of semantic. So what is it that a server can do in this case? Well, it receives a request for index.html, and then immediately afterwards, these 3 ones. And it can build a cache and say, hey, index.html and these other 3 are correlated. So I can build a cache in this way. And the next time that I'm requesting the same web page, but now using HTTP2 and push, this happens. I make a request for index.html, and the server says, oh, you will need this JavaScript, this CSS, and this background image. Here you go, in one step. So we just went from 3 round trips to 1. Remember the $1 million that the guys were doing before? This is all about it. So, who's going back to HTTP 1.1 here? Still no one? Cool. So let's see when this is all happening. Okay? So the HTTP2 specification is now officially an RFC. It means it's a standard. Everybody implements it. The browsers implements it since now, I think, many months, probably 1 year. So Firefox 34, Chrome 38. Firefox, we're now at 37, 38, I think. Chrome, we're now at 42, something. Internet Explorer 11, we're now at 10. No, maybe 11 is out. But yeah, you got the point. And all the major browsers, all the major servers and websites, they are moving to HTTP2. for the reason that I told you before. They moved to HTTP2 because they're making fantastillions of dollars if they do, right? So our own website, httpswebtite.com, it is served by Jetty on HTTP2. So you open up a browser, a recent browser, you just connect to our website, and you're going to be served in HTTP2 by Jetty, okay? But it's Twitter, Google, Facebook, you name it, like every major website goes there. So let's see who. Are you ready? I mean, okay, it's there. Browsers do it. What tools do I have? Okay, so who is actually doing HTTP2? So regarding tools, curl and Wireshark, they are Unix tools for network communication stuff. They support HTTP2. There are, at this page, there are 35 plus implementations in basically any language. Like you can find Java, C, C++, Go, Node.js, Erlang, Haskell, whatever. You have a language, you name it, there is an HTTP2 implementation, pretty much a server one, but you can also find clients one. And what about Java? Let's go into the details of that. The cool thing about Java is that it is all made by the container. You don't have to change a single line in your web application. You just throw away the server container that you're using that doesn't support HTTP2. You put in a new one that does, and you just deploy the new WAR into it. You're done. And now you're HTTP2 enabled. Okay? And the push functionalities are provided typically by servers and frameworks or frameworks. For now, just by servers. We'll see in the future. Maybe JSF, it is going to leverage the push functionalities. But for now, for example, in Jetty, we have a simple servlet filter that you put in front of your application, and that just gives you the push functionality out of the box. There's basically one single change that you have to make to your web.xml. Just define that filter. Map it to /star, done. Push enabled, okay? So do you have an action to make? Well, maybe you want to remove all those hacks that you were using. Remember, domain spriting, image spriting, domain sharding and stuff. Complications, just because of workaround of HTTP 1.1, you can remove them. They're not needed anymore. So HTTP2 servers require JDK 8. So you need to update to that if you haven't already. This is because only JDK 8 provides the strong ciphers that are required by HTTP2. So you have to use it. If you're just doing clear text, server to server, you can run on JDK 7 depending on the server implementation. Like in Jetty, we actually require JDK 8, but there could be other implementation that actually work with JDK 7 for server-to-server clear text, HTTP2. So Servlet 4.0, the next version of the servlet, will support HTTP2. We'll see how. It's going to be, say, 1 year in the future for now. But the good thing is that there is a lot of activity. There is this JAP 110 for defining an HTTP2 client API that is going to be into JDK 9. This client will have a much better interface than URL connection, and it is going to support HTTP2 out of the box. So it will have a semantic proper for HTTP2. Also, they're defining, as part of this effort, also a WebSocket client API, but that's kind of in parallel. There's also a more technical JAP called 244 for the TLS ALPN extension. This is more a technical detail that it is required, though, in order for HTTP2 to work. But again, I am personally working with the JDK team that is working on these two JAPs in order to make sure that they enter JDK 9, because it is really important to support HTTP2 out of the box and not wait for JDK 10, which could be like 3-4 years from now. We don't want to wait 3-4 years in order to be able to use HTTP2 with Java. So in the Java world, we have, of course, Jetty supporting HTTP2. We have a server, we also have a client, and we have a live website. Netty is supporting it. It's used on Twitter, for example, and stuff. Undertow is supporting HTTP2. OK HTTP is a client only for Android, so you can use it there as well. And in particular for the Jerry stuff, I mean, this is how you're going to use the HTTP2 client. So this is the standard way that you create an HTTP one-to-one client, and this is the only modification that you have to make in order to switch to HTTP2. That's it, one line change. All right, so let's look at a little demo, because I fear that some of you is not still convinced. So let me see if I can go. Oh, here we go. So what I've done here, I've slowed down the localhost interface of my computer to simulate a network round trip of 200 milliseconds. Okay, this is typical. 200 milliseconds is like going from Europe to United States servers. If you're a browser in Europe and server in the United States, it's typical 200 milliseconds. So it's a normal thing. So the page that follows these links is a page that contains, let me just restart the server quickly. So just do this and this. Okay, so the page that follows, it's a page made of many chunk of images that form together, that form a bigger image, okay? This is to simulate the fact that for a single page, you have to request multiple correlated resources in order to render the page, all right? So imagine that every single image piece is actually a JavaScript or a CSS or a small image or the favorite icon or background images and stuff like that. So when you actually click on, let me just find the pointer here. There we go. Okay. Now, when I click here, we're going to see how it's going to look in the HTTP one-to-one world. Click. Okay, so that was kind of slow, but that's what you get when you get 200 milliseconds delay in network round trips, okay? Have you noticed that the first two images were kind of arriving really slow, but then as the time passes, the images were coming a little bit faster? This is actually a TCP effect called the Tcp False Start, okay? Slow start, sorry. So it basically means this: when you open a TCP connection, you have to send back and forth TCP packets in order to warm up the connection. The more packets you send without errors, the more the TCP window, the amount of bytes that you can actually send in flights gets enlarged. Okay, so you need to warm up these connections before actually getting the full speed that you can get out of these connections. And of course, if you open 6 connections in HTTP one-to-one, then you have to warm up each of these ones, right? Contrast this with HTTP2, where you just open a single connection and you just shove everything into it. The connection gets hot really fast. And that's very good because then it allows you to get up to speed and very hot and larger bandwidth much faster than HTTP 1.1. So in fact, if we reload the page, well, now probably the browser has timed out, but if I reload again, click, you see it's faster because now the connection has been warmed up, all right? So let's go back and now try HTTP2. Click. Boom. You notice the difference? This is what makes you billions of dollars. Not you, but, your business. Okay. A question for you guys. Who's moving to HTTP2 now? Okay, cool, guys. Thanks. So, let's go back to the presentation. Oh, by the way, it's not a trick. Let me refresh this. Oh, I lost my pointer again. Okay, so you actually see a 200 millisecond delay between when I click and when everything comes back, but that's the delay that I have to send the initial request. But then what the server is doing, oh, you're requesting this HTML page, but I know that you need this 24 resources associated with it. Get them all, right? And then when they arrive in the browser say, oh, I'm parsing the HTML. Look, I need this image. Oh, I already have it. Let's render it, okay? So it's really fast because of this. So it's not like a trick. And note that you can find many examples of this online. Now, I didn't connect my computer to the internet, but you can go, for example, to http2.golang.org, the Go language from Google. They have a very similar demo with, I think, the pixelated image is like more than 100. And you can really tell the difference over a real network. This one is kind of simulated over localhost, blah, blah, blah. I'm cheating, okay? But I'm not. You can actually go online. There are examples online that do exactly this example, and they just work incredibly better with HTTP2. So, yes, I'm back to the slides. So, conclusions. No changes for developers, okay? If you have written your web application, it's going to be good. You're going to be either no changes or very little changes. The servlet API is going to be backward compatible, okay? Frameworks like JSF could be leveraging these new features of HTTP2. No more hacks to work around limitations of the old HTTP 1.1 protocol, okay? And JDK 9 supporting HTTP2 out of the box. You're going to have the stuff baked into the JDK from JDK 9 for the rest of the future. So it's going to be good. There are a little bit of changes for deployers, though. So those who manages the actual physical infrastructure. If you want to have your website online using HTTP2, you have to use TLS. If you haven't already, you have to buy the certificates. You have to put up a process in your company to renew the certificates every year or every 2 years or whatever, and remember to do that. You have to upgrade your server container, and you got to go to Jerry 9 or Undertow or Netty or whatever you're using. And you have to upgrade your network infrastructure as well. You have to talk with the load balancer vendors and say to them, I am going to deploy HTTP2. Is your load balancer supporting it? Because if it's not, then you're basically losing all the benefits of HTTP2. The good news is that most of the vendors, they did not stay back. They already updated their products to HTTP2 to support HTTP2. So it's probably just going to, lift the phone, call them and say, hey, we have this old machine here. Can we just get an upgrade to support HTTP2 because we really want, okay? Why do you want to do that? Because it's money again, right? So to sum up this slide, and thanks. Okay. So let me ask, how many of you were submitted a question to slido.com? No one? Okay. Do you have sorry. Okay, does HTTP2 impose any restrictions on the number of connections between client and server? No. But typically what happens is that the number of streams that you can open over a single TCP connection is in the order of 1,000 or 500 maybe. That's totally more than enough to serve any web page of today and for the next many years, I guess. So typically what they do is browsers, they open one connection only from the server. And by the way, reflect on this. You go to a conference, there's 500 people, like this one, and they have Wi-Fi network, all right? We are all connected with maybe one device, maybe more than that, okay? Just imagine for the device that is offering the Wi-Fi to support 500 connection, or 500 times 6 equal 3,000 connections. It makes a big difference on the actual Wi-Fi element scalability, right? So you really want to go there because HTTP is so much cheaper on resources than HTTP 1.1 that it makes you money. You can buy, for example, smaller servers on the cloud because you don't need all the power that you needed with HTTP 1.1. You need less CPU to parse the protocol. You need less bigger machine because you don't need those many connections to the server. So it's good. Hello to the other anonymous. Any other questions from the audience? Yes. Yes, so I'll go into a little bit of detail on how the push works but this is, so there's nothing specified in the HTTP2 specification. There's just support at the protocol level. But how Jetty implemented HTTP2 push. Every time you make a request for a primary resource, let's say there is this normal request, right? And then when a secondary request that belongs to that primary resource comes to the server, it contains a special header that is called the referrer header that says this secondary resource has been requested because the referrer is the primary resource, the HTML file, all right? And similarly, when I request the background image from the CSS, the referrer header points to the CSS, and the CSS points to the primary resource, the HTML, right? So the way we build this cache in Jetty is exactly in this way. We leverage the referrer header. We leverage the fact that the requests come in a very short amount of time following the primary resource, okay? And we just build the cache together. And then we also limit by the number of associated resources. So we don't associate like an infinite number of resources. You can configure the filter to say, just take the first 8. And all the rest will be requested normally. Okay, but the first 8, just correlate them together and then push them back. So that's the mechanism that we use in Jetty to do this. There are other mechanisms. They're typically configurable. Like, for example, I think Undertow uses a similar mechanism, and it is also configurable in Undertow, and so forth. So Google is probably using a different one in their servers, but yes, you can do these things. More questions? Tomcat support for HTTP2. So Tomcat, Mark Thomas, which is the main developer behind Tomcat, has said that there will not be HTTP2 for Tomcat until Tomcat 9. And this is going to be like a lot in the future. Probably, I don't know exactly the Tomcat schedule, but 6 months, maybe 1 year, because Tomcat 9 is probably going to be on JDK 9 support, so it is going to take a while, unfortunately. So it's probably the only server that has remained, well, probably also Glassfish, that has remained back. It didn't follow the evolution of this protocol. So backward compatibility for all clients, 100%. All clients will try to connect to an HTTP2 enabled server, and the way they connect, the server is able to say, oh, you're not speaking HTTP2? Fine, I'm speaking HTTP 1.1 with you. So totally transparent. If you're using Netscape 4 or Internet Explorer 10, then you're going to be just fine. Slower, but fine. So what else? Does HTTP2 support pickle jar opening issue? Waka waka. I don't know what that is. Oh, pickle jar is, okay, gotcha. So I don't think it deserves a question. I don't know if it is something real or it is a joke, but if it's a joke, good joke. Otherwise, I didn't understand the joke. Is there support for REST request caching? It's a strange question, but the answer is it's an orthogonal problem, all right? So what happens is that you're just transporting strawberries. Rather than using a truck, very slow and very old, you're using a Ferrari, okay? That's the difference. So, but the strawberries are carried from A to B in the same way. They will arrive from A to B. So a REST request is basically built on top of HTTP. It doesn't matter if you use a truck or a Ferrari to move the REST request, and it doesn't matter if you have a cache layer in between. All the rest would just work seamlessly. It's just the transport mechanism that changes. So whether you're using a Ferrari or a truck, but all the rest is completely backwards compatible. So yeah, I guess the answer is yes then. I mean, I don't know exactly how you can do REST caching, but if you have let me put it in this way. If you're doing response caching in the server, then it's going to be fine. If you have an intermediary that does request caching, then that's a problem, because now the requests are fully encrypted from end to end, and the intermediary will not have any chance to understand that the response is cacheable, and therefore to respond you quickly because it's closer to you, because it's all encrypted. So it will have no idea on how to cache things. But if your cache is on the server, then yes, it will work. So you don't have to go to the database, for example. Less open connection, but more bandwidth, right? No, it's so the bandwidth, it's a little bit tricky because so if you compare HTTP 1.1 over TLS and HTTP 2 over TLS, HTTP 2 over TLS sends less bytes over the network in general, like in average. So it's less bandwidth. If you compare clear text HTTP 1.1 and HTTP 2, which has to be over TLS, then it's kind of apple to oranges, but so you have the overhead of the TLS protocol, but you have a little bit less on the HTTP 2 protocol, so it's probably like a little bit in favor of HTTP 1.1 clear text. But the point is not going from, I don't know, 100 bytes to 95 or 90 even. The point is all the rest good that you get with HTTP 2. You get push, you get multiplexing, you get less connections, you get less resources on the service that you need, less file descriptors open on your server, less kernel objects that map those file descriptors, and smaller memory, smaller CPU. It's all good. I mean, you pay less for that particular VM on the cloud. If HTTP 2 requires TLS, how small website going to overcome cost of TLS certificate? It's a good question. Thank you. There are free certificates now, but typically, I don't know, it costs like, you can find a certificate for like, I don't know, maybe $30 per year or something like that. So can you really afford to spend $30 and then make your web pages so fast that you get all the benefits that I show you in that slide? Maybe you get 10% more revenue. Can you really afford to spend $30 on a TLS certificate? Well, maybe the answer is yes. If it's your own personal website, blog or whatever, then maybe why don't you go to a platform that actually supports HTTP 2 by default? It offers you this capability, and that's it, you're done. Just to give you an idea, right? Our own website is made in WordPress. It's PHP, okay? But what do? We have Jet in the front. We have built a communication layer between Jetty and PHP. So we just receive the request in HTTP2 from the client. We call the PHP. We tell WordPress to render the page. We get back the HTML. We just convert that into HTTP2 and we send it back to the client. So, you know, it's not only Java. You can put your blog using WordPress and Jetty in the front and, you know, just go through HTTP2. Yes, you will need a certificate. Yes, it's $30 or free. But yeah, it's a small cost that you have to pay. So, okay, I think I answered them all. Sorry, the last one. So HTTP2 will get best performance results for bad optimized site. Already optimized sites won't give so much good result. No. So the problem is that even if your site is completely optimized, take, for example, the CNN.com website. The CNN.com website, I bet it's highly optimized to render as fast as possible, okay? Still, it makes 95 requests to the servers. Not only one server, but multiple servers, okay? Now, if you just have 6 connection open, 6 and back, 6 and back, and by the time you arrive at 95, it's a lot of back and forth, okay? With HTTP2, what you can do is you make the request for the primary page, you get back the HTML, the browser says, oh, I need 10 JavaScripts here. Bam! All together in that single connection, all together. They don't need to do 6 and then wait for the other 4, right? And then continues parsing the HTML and say, oh, I have a background image here, background image there, another background image here. Bam! Them over in the same connection. As soon as you find the resources, bam! Over to the connections, back to the server. It doesn't have to wait. So it's not really a matter of optimize the site or not. It's just that you're running a Ferrari rather than running an old truck. Yeah, I mean, you're transporting the same stuff, but you're just going faster, period. You just won a Ferrari to the lottery. So someone gave you a Ferrari for free. It's like in Jetty, it's open source, it's free. So you just get a Ferrari for free. Just use it. No more questions. Okay. Thank you for coming. I'll be around at the conference here tomorrow, so you can just find me in the corridors and just, you know, cover me with questions. And thank you for coming.